Hello, welcome to Enots Engineering. I'm Alan. In today's video I make a new backplate for my 4-jaw chuck. This one is the old backplate. As you can see from the holes in it, it's been used on at least 2 chucks. When I got the 4-jaw chuck, this was already attached and the thread fitted the Boxford, so I assumed it had been used on a similar lathe to a Boxford. But I've always had problems with this chuck in that when I'm doing things like parting off or things that put like knurling, operations that put a lot of side pressure on the chuck, I have vibration problems, and I found out why. The register on the back of this chuck was 30 thou oversize, so the only thing locating the chuck was the face. And I had some more problems when I purchased a replacement backplate. The backplate had a Boxford thread already cut in it, but the OD was 125 millimeters and I needed 127, which is around 5 inches. See how I overcome the problem and how I got the backplate to fit properly. Let's go into the workshop and find out. Now, for some time I've had problems with my 4-jaw chuck. This is the backplate off the 4-jaw chuck. As you see, it's been used on a couple of different chucks before I had it. And because the thread screwed on, I assumed that it was the correct size for the lathe. But being that I've had problems with vibration, especially when parting off, I thought I'd look into it a bit more. As you can see on here, there's a bit of play in the thread, so that doesn't go until the plate touches the spindle, then it locks it up. All I'm relying on this backplate is the face and the register to hold it in position. That's what it should do. But then when I measured the register on the back, the diameter of the register should be 1.5 inches. That's giving me a reading of 1 thou under 1.5 inches. If I take a reading of the bore on the back, so the diameter is 29 thou oversize, and the only thing that keeps the chuck true is the face, so I will get some run out. I thought, right, I'll get a new chuck mounting plate and fit that to the chuck. I came across one that was supposed to have the right thread and supposed to be the right size. This is it. It's already been machined. The thread in this is already cut for a Boxford, and the bore diameter, I thought it was a 5-inch one, but it's not. I asked my brother to weld up the outside, because the outside of this chuck mounting plate is 125 millimeter, and I need a diameter of 5 inches, which is 127. It's 2 millimeter down. By welding the diameter all the way round, I'm hoping I can build it up and turn it down to the correct size. The outside just locates the chuck. As long as it's touching the 5-inch all the way around the marks, it'll locate it. Then I have to drill holes in the backplate. It goes on there about 3 turns and locks. When the thread locks, you can see the gap there. It's still got to go on another 2 or 3 turns. It's that tight now that it won't go on any further. First of all, I need to set it up on a faceplate so I can just skim about 2 or 3 thou off the thread, and then once the thread fits I can then put this back on the lathe. This is the back of the chuck, 5-inch register. The face can be flat, and then through the chuck come these bolts which come out of the 4 holes, so that when you fit the chuck, it goes straight through the chuck into the back plate. The back plate holds it in position. From the front, those are the cap heads. I've clamped the chuck back plate to a face plate, and I'm just checking the run out of the face that's already been machined, and then I'll check the bore run out. Each division's 1/10 on that. That's a couple of tenths on that face. Now I'll check the bore run out. On the DTI, I'm using my adapter that I made. Turn it round to go into the bore. You can see there a little kick. That's where they've cut the thread through the register size. That's less than half a thou. There's the gear selection for the 8 teeth per inch. Remember, this is a metric lathe, so I have to have a conversion gear. The conversion gear is 135 teeth on the outside and 127 teeth. And the two gears I'm using, 36 tooth on the stud and 32 on the screw. I'm just going to grind the tool now. I'm just using this little piece of a broken tap, I think it is. And what I'm doing is grinding an angle of 27.5 degrees on that side. Then I'll put 27.5 on there, giving me the 55-degree angle for the thread. To line the tool up with the thread, I've just taken the faceplate off. Using the headstock thread, I'm lining the tool up to get it square so that each side of the tool touching the V in the thread. I've set up a dial indicator on the saddle so that when this goes round once back to 0, I know that the cutting tool is at the back of the thread. I've lined the tool up, so I'll just send it in. Wind it back in, reverse it. Wind it back to the cutting position, forward. Back to the cutting position, forward. I'm only taking a small amount off each time, just rubbing, because that's all it needs. Now I've taken a few light cuts in there, and it's mainly been taking it out of the bottom of the thread on the tip of the tool. You can see from the red mark that I put on there, I've not yet cut any out of the angle of the thread, it's more or less the root depth. So I'll risk it now. I've taken 2 or 3 cuts on there and see whether it'll fit the headstock. It goes on okay now. Yeah, once it locks up, there's no play in it. I'll take that off the faceplate and fix it to the lathe. That's a run out of the face, which is about half a thou. So my next job is to face this off, then work on this OD. That's the machining of the backplate. There's the old one. This is the new one I've made. There we go. It's not as loose. Plus the diameter of the bore on the original one, that's 0. On this one, the new one, 1.502, so that's 2 thou over. Now I'm just getting ready for drilling the holes to be tapped for the backplate. The backplate's on the back of the chuck. I fitted a handle in there, just a piece of steel plate, so I can hold the chuck. I'm not using a vise because I want the bottom to be square to the table, which it is now. This is an 8.5mm drill for a 10mm hole, but as you can see, if I put that in there, I could be anywhere. So I need to get the hole in the right position. So what I've done is made a small bush, 10.5 on the outside, 8.5 on the inside. So that bush can go into the hole. Tap it down. Now it's level with the base. Now when I put the drill in, there's a bit of play there, but it's located in the centre of the hole. What I've decided to do is tap this hole first, because if this plate turns on the bottom and you're not aware of it, you could be drilling a hole out of position again. So I'll tap this first. That's got it. So what I'll do is put the chuck plate back, put this screw in to locate that, and then drill the second hole. Before I put the drill down there, I'll just put the bush in for the last one. So what I've done is just run the file across the back of these holes to take any burr off the outside of the hole, and just double check the diameter now. .997. It's about 3 thou down. We can fit the chuck on that now. Okay, I finished the tapping and I've screwed the bolts in to hold the chuck to the back plate. I've put the nuts back on the chuck mainly because I don't want to lose them, and I know they fit those bolts. So the run out of the body is 1, 2.5. I'll zero that. 0, 1, 2, 2.5. The face is running out about 2.5 thou on a 6-inch diameter. It's 2 thou there, 1 thou, 0, about half a thou down, so it's 2.5 thou. Each big division is a thou, which is not too bad. Well, that's another job done, and we'll see how that performs. That's it for today. Hope that was interesting, and we'll see you next time on Enots Engineering.